McElveen, and this is another round of guided math practice or teacher video work. So we have a new problem to think through together. Every day, Lewis rides his bicycle from home to school, then to the library, and then back home. Here's a diagram. Lewis is home, to school, to the library, back home. How many total miles does Lewis travel if he rides his bicycle on this route for 5 consecutive days? Consecutive means in a row. I'm going to read the problem again. Every day, Lewis rides his bicycle from home to school, then to the library, and then back home. How many total miles does Lewis travel if he rides his bicycle on this route for 5 consecutive days? For 5 days in a row. First, I want to really make sure I understand the story. So, there's this kid, he rides his bike. He rides his bike to school. After school, he rides his bike to the library, and then from the library, he rides his bike home. That's probably like kids who, they might ride their bike to school, and then they ride their bike to the community center, and then they ride their bike home. So I can relate to that. That's like kids here. When I'm thinking about 5 days in a row and they're talking about school, I bet it's like Monday, Tuesday, Wednesday, Thursday, Friday, a week of school. I'm going to think through the problem again with the X. Okay, so first, important numbers. I know from home to school is 1 4/5 miles. From school to the library is just 3/5 of a mile. And from the library to home is 1 2/5 miles. Oh, I already noticed they all have the same denominator. That's pretty cool. So then it says, for important words, how many total miles? Total miles does he travel? So total miles traveled. If he rides his bike on this route, so this route, another way to say this is this path, on this path for 5 days in a row. 5 days in a row. Remember, pause this whenever you need to so you can catch up with the writing. Now I think I'm going to make a chart again. So let's see, he goes from home to school, and from home to school is 1 4/5 miles, and then he also goes from school to the library, and that's 3/5 miles, and then library to home is 1 2/5 miles. Okay, so he does those things every single day. So he does that is one day, and then he does the same thing. I'm going to run out of space, but he does the same thing another day, and another day. 1 2 3. I'm going to add up here. 4, 5. Each of those days he does that much. So I'm going to add these together to find out how much he travels in one day. So it would be 1 4/5 plus 3/5 plus 1 2/5. And like before, I'm going to estimate. I noticed that not a lot of people estimated when they did works with their partners and by themselves last week. I hope they do today. 1 4/5, that's one whole. 4/5 is almost another whole because it's only 1/5 away from 5/5. I'm going to call that 2 plus 3/5. That's kind of halfway between 0 and 1. It's a little bit bigger than 1/2, but I'll call it 1/2. And then 1 2/5. 2/5 is a little bit less than 1/2, but there's one whole. I might call that 1 1/2. So my estimate, I have my whole numbers, that's 3. 1/2 plus 1/2 is 1 whole. So I think he will travel about 4 miles in 1 day. That's just this day. We have to think of Monday, Tuesday, Wednesday, Thursday, Friday. I almost forgot that it was 5 days is what it asks about, but I wrote it here and I underlined it. So 5 days, 4 miles each day would be like 4 plus 4 plus 4 plus 4 plus 4, or faster, 5 times 4 equals 20. Wow, around 20 miles each day. Okay, so now I'm going to do some actual work. I'm going to scoot this up so I have a little bit more workspace. I have my problem. 1 4/5 plus 3/5 plus 1 2/5 equals, I'm going to combine the whole numbers first. I notice these are all the same denominator. I don't have to change anything, which is nice for once. 1 and 1 is 2. My denominator is 5. 4 plus 3 is 7. 7, 8, 9, and 9/5. I do have to do something though. I see that this fraction is an improper fraction, or a fraction greater than 1, because the numerator is bigger than the denominator. So I'm going to draw a picture of this whole thing. I'm going to do 1 whole, 2 wholes, 1, 2. If you have another strategy for changing a mixed number, an improper fraction into a mixed number, go ahead and try it out. And then I'm going to draw 9/5. So I have to do fifths. 1, 2, 3, 4. Just 4 lines. 1, 2, 3, 4, 5. I have to keep going. 1, 2, 3, 4, 5, 6, 7, 8, 9/5. So I know that this 1, 2, 3 is 3 wholes, and my leftover fraction is 1, 2, 3, 4, 4/5 miles. And I almost forgot again. I'm not done. This is just 1 day. This is just Monday. But he did this for 5 days. But I feel pretty good so far because 3 4/5 is pretty close to 4. So now I need to do some more adding, because he did 3 4/5 on Monday, then 3 4/5 on Tuesday, then 3 4/5 on Wednesday, and then Thursday, and then Friday. So scoot over this way, some more space. 3 4/5 plus 3 4/5 plus 3 4/5 plus, let me make sure I'm keeping track, Monday, Tuesday, Wednesday, Thursday, 3 4/5. Here's Friday, 3 4/5. I'll do the whole numbers first. 3, 6, 9, 12, 15. My denominator is still 5, thank goodness. Now I'll just count up all of the 4s. 4, 8, 12, 16, 20. 15 20/5. I notice again I have to change this. It's an improper fraction. I'm going to scoot my paper up a little bit more again. So I have 15. I'm not going to draw 15 whole boxes, but I need to remember it. I'm just going to do my 20/5. That will do a little less time. Again, if you have a different strategy and it works for you, go ahead and use it. 1, 2, 3, 4, 5 parts. 1, 2, 3, 4, 5. Another. 6, 7, 8, 9, 10. Another. 11, 12, 13, 14, 15. Almost there. 16, 17, 18, 19, 20. 20/5. I have 1, 2, 3, 4 here. And I had 15 here. So 15 wholes and 4 wholes. 15 plus 4 equals 19 miles. He travels 19 miles on his bike for 5 consecutive days. which is very close to my estimate of 20 miles. So I'm pretty sure I have my final answer. Use this when you work with your partner on this problem, and then when you solve this problem independently.